Welcome to our talk about the MySQL 8.0 migration at Meta. I'm Herman. I'm a software engineer working on MySQL. I've been working in database engineering for a few years now.
And I'm Pradeep. I'm also in the MySQL team, but I'm on the production engineering side of things. So I'm also at Meta for close to 5+ years now.
Cool. We'll talk a bit about some of the process that we went through in order to make the migration happen, both from the porting of patches to how we did the testing and migration. We'll cover some specific production pains that we actually saw, and probably a few conclusions at the end. So feel free to stop us if you have any questions along the way. We'll be happy to answer them. So as a lot of people probably know, we have a lot of changes on top of MySQL. We've been running with 5.6 for a long time. And I think we've started the migration to 8.0 back in September 2017 with 8.04. Back then, we had about 1,700 patches on top of 5.6. And by the time we finished around September 2020, we probably had about 2,400 patches. The bulk of the changes were migrated in early 2020. Since then, we have still been migrating a lot of our workloads between 5.6 to 8.0, so we've been double committing a lot of our changes to the two branches. But we're finally getting to the point where almost all of our workloads are going to be on 8.0, so that we can finally retire 5.6. We've dropped about 700 patches along the way, so we've evaluated probably close to 2,700 patches at this point. We've been rebasing roughly once a year. We went from 8.04 to 8.11. 8.017 was when we first started shipping the InnoDB server side of things. 8.020 was when we started shipping MyRocks. And now we're currently on 8.023. And the next target for our rebase is 8.028. So we've been able to start catching up to what is coming up from upstream and to be able to run their latest software. So this was a pretty big effort. It took about 10 engineers working over the course of the 2 years, contributing at different times to make the migration happen. We basically had to flag every single patch, kind of justify whether or not it should be ported, and keep track of all these notes. Because oftentimes what we found was a couple years later, someone was asking why a certain feature wasn't ported. We can actually go back and see who the engineer who looked at the case was to figure out what was the reasoning and whether that was still valid or not. We've also gotten a lot of help from Percona, who are experts in MySQL here, to help with porting of these patches. As we started focusing more on testing and migration, we were able to get help from companies like Percona for the actual porting of patches itself. And this is one of the benefits that we've had working on open source, having all of our source available in GitHub. When we broke down the release, we had 3 major milestones. The first was shipping all of the client applications, which included MySQL dump, MySQL bin log, all of the connectors. And that we shipped back in 8.013, so probably about 3 years ago at this point. InnoDB was the next target. So we target all of our InnoDB workloads to be shipping in 8.017. We actually found some issues with it, and so we postponed it to 8.020. And that sort of came out early 2020. And then lastly, we got all the MyRocks changes ported over, built 8.0 to work with both MyRocks and InnoDB, and that we've basically shipped in 8.020. And we've updated everything to 8.023 at this point. So yeah, this is a lot of work overall. Some of the highlights are some of the more complicated features that we've had to deal with. MyRocks, because 8.0 requires you to run InnoDB, and since MyRocks is also a transactional storage engine, we had a lot of problems that we had to resolve around crash recovery of both engines running at the same time. So we had to add a bunch of new code for that. We've had to add native partitioning support to MyRocks as well, because that was dropped after 5.7. Some additional features that we've supported, like read-only database, that we had to re-implement directly in the data dictionary in 8.0. Json Compatibility, this was a hard one because we ended up adding a lot of JSON functionality in 5.6. And those JSON functions had exactly the same name and arguments as 8.0, but they had completely different semantics. So we had to figure out how to migrate the users who had these JSON functions over to the new build. And we were able to find ways to translate the older 5.6 format to the new 8.0 format. So we were able to seamlessly upgrade them, but it wasn't perfect. There were certain edge cases where if you wrote stuff out to disk and then read them back, it wouldn't behave the same way. A couple of other features, InnoDB reduced double write. This is something we depend heavily on. And 8.0.20 completely changed how the redo log worked. So we had to re-implement this. And that took a couple of months of effort as well. And lastly, probably our most complex feature was a form of dependency parallel replication, which is row-based. It doesn't require any kind of event marking on the source side. It just looks at the rows and generates a dependency graph on the destination side for applying. Now, we weren't quite sure we needed this, but we also felt that there were certain really write-heavy workloads which could run into problems where if you had a 5.6 primary and an 8.0 secondary trying to catch up, we needed this feature in order for our 8.0 secondaries to catch up. And indeed, we did come across a number of cases in that. But that feature probably took us about 6 months overall to complete porting. So, any questions so far? Yeah.
So since in 8.0, if your engine needs partitioning, you have to implement it. And you said that you guys implemented partitioning in MyRocks. Should I make the backwards assumption that you guys have MyRocks tables in which you partition?
Yes. So we have some use cases where MyRocks is using partition tables, and in order to support those use cases, we had to backport that. So, okay. And then Pradeep will talk about testing migration.
Cool. Thanks, Herman. So as you can imagine, this is not an easy effort. And to get all of Meta's 5.6 deployment to 8.0 meant we had to spend a lot of time in figuring out how we want to test our existing code, automation tooling, what our users are used to working with, and also coming up with a migration plan. And you want this to be as automated as possible. So I'm going to kind of describe briefly what automation we put in so that this entire process was basically landing config changes and migration was happening and taken care automatically. Before I get started, I wanted to focus on some of the terminology I'll be using throughout the presentation so it's familiar with everyone. So what's an instance? When I refer to an instance, it's basically a host and port combination where a MySQL process is running and it is hosting a database. When I mention shard, it is nothing but one MySQL database in a MySQL instance. This is just an example naming convention. And when I mention a replica set, it is nothing but a collection of MySQL instances with one primary and many secondaries. And number of secondaries depend on application's requirement. And yeah, this is what the replica set would look like. And service discovery is nothing but how our applications discover where to connect to and write to. Yeah, and this is putting it together, shards hosted on replica sets backed by MySQL instances. So yeah, so shards, replica set instances, I'll be frequently using those terms. Coming to migration, so I'm going to talk about a bunch of things here. Some of the prerequisite we had to have to start the process, automation validation, working to improve our copy tools and backup tooling, rolling the rollout process, and some of the metrics we thought were important during the migration. Yeah, row-based replication is interesting. We found out that moving to RBR will allow us to use a lot of new 8.0 features. So we kind of made this as a dependency to convert all of our statement-based application to row-based application. Most of our replica sets were already running RBR when we approached the 8.0, but there were some still on SBR. We found out that they had many tables without primary keys, so we made sure that every single production table at Meta has a primary key, and we also added a feature where you cannot create a table. You create table statement would fail without a primary key. And yeah, this actually was beneficial. Herman will talk about it later, why RBR helped mitigate some of the production issues we saw with 8.0 later. So yeah, this was a prereq. So once we had this, that's what made that the replica set is eligible for 8.0 migration. Yeah, automation validation. So I think it was important for us to make sure the tooling works. So what we ended up doing was we doubled down on improving our testing infrastructure. We essentially implemented a test environment where we had integration tests, which would run against a completely 5.6 setup, and will also run against a completely 8.0 setup, have some assertions and verify the results. And if we found breakages, we would go back and fix either the automation or work with Herman and team to fix the server. We found a lot of issues via this approach, so it was very impactful in a way to actually have focus on building out this test framework. We leveraged virtual machines to create virtual replica sets, virtual instances, so we could spin up many number of these and do testing. Okay, so what are the problems we saw? So a lot of things around type of formatting in error logs, output changes in MySQL dump, even like things like if you were to query information schema table, the names of the columns appear capitalized, but our automation were calling it. So we had to like figure out how to denormalize all of that. So there's like a lot of code, and even like some of the application developers had implemented their tooling on reading information schema tables, so those all broke. So we had to like fix a bunch of code around that. So this was like discovered via this process. Collation settings, yeah, so the new collation settings were not compatible with 5.6, so we had to do a bunch of work around that. Error codes, this was interesting. So we had remediations or automatic detection of fixing things when they're broken based on error codes in MySQL Server. I'll give you an example. So when you cannot catch up a secondary, if it's no longer able to like find the bin log, it will fail with 1236 error code in like 5.6 version. In 8.0, this moved to 13114. So I mean, I know this number because I was looking at, so I know most of the error code. So basically we had to like do if 5.6, this is the error code, if 8.0, this is the error code. So something of that sort we learned from this process. Deprecation of FRM files. So given the move to data dictionary, we had some schema change tools relying on the changes made to the FRM files to detect. So this was like hidden in code somewhere, so we had to fix that as well. And dynamic privileges. So this is a new security feature in 8.0. So we had to add support in our grants management system so that we could add proper grants for extra backup to work and other things to work because of new dynamic privileges. So yeah, automation validation essentially helped identify this even before we actually went ahead with the migration. So we were able to address all of these issues before we could start. So we had like a checklist of things, validated every automation tooling, and then start the actual production deployment. The next interesting stuff I would say is reserved keywords. So since we are moving from 5.6 to 8.0, 8.0 it felt like we had a lot of new reserved keywords, and basically queries had instant failures. So yeah. So and the group rank were like really popular in our code. And so it was like immediate 1064 errors, and applications had like, oh, my queries are not working. So we had to file like tickets and tasks to thousands of application developers. Hey, this will not work. You have to escape with like a backtick, or you have to alias it to something else. Again, so for this, we built out like a testing pipeline. What essentially it did was we had a test instance which had the schema from production for every single shard or database, and then we replayed the same traffic onto the test instance and verified if the query passes or fails. And this way, and we also increased the sampling rate for all of these errors to be 100%. So all our client logs had evidence of like all possible failures because of this change. So this was another interesting thing we discovered during migration. Okay, so I talked about like some of the toolings we did, right? So this is another thing we made sure to be confident about the migration. So Luke talked about data correctness at scale at Meta last evening. So check out his talk. That has more details about the actual technology and the actual production issues we found with the tooling. So essentially two types of data correctness. One is like the regular data correctness is where you compare 5.6 and 8.0 and you start transaction with a consistent snapshot and make sure the data in both versions are the same. And that is the signal to say that we have not lost data, and that 8.0 version is good. Then we had select correctness. This is essentially for figuring out the same select query would execute in the same time between 5, 6 servers. So this helped us identify query plan regressions where we saw certain queries would take longer to execute, or optimizer chose a wrong plan, and we either resolve those via fixes in the server or like tweaking some optimizer settings, or in some cases having the customer rewrite queries. So this again gave us more confidence in the migration process. Cool. So I'm going to talk about the migration. I'm going to mention copy. When I mention copy, it's essentially adding a new copy of data or replacing a existing copy of like an instance in a replica set. This is the rough steps which our copy process goes through: allocate a spare, set it up with MySQL properly, schedule the copy. For the 8.0 migration, since we were going from 5.6 to 8.0, the first copy of the instance in the replica set had to be a logical copy. So we had to essentially do a MySQL dump from 5.6, load it onto 8.0. Very slow because MySQL dump, and it was heavily influenced by the size of the shard. Larger the shard, longer the copy times. So we did as much as we can to improve that process, to speed it up, to have the first copy available. And once we had the copy, then it's all about using extra backup to create more 8.0 copies. Sorry?
Not native learning.
Not yet.
And not my dumper? That would have made your dumps go so much faster.
No. Don't have an answer, but yeah, we have been using MySQL dump. Yeah. Anyways.
This is both for
5, 6, and 8.
And MyRocks, yeah.
So you were doing the same process.
Yep. So so we had to work with Percona to get the latest extra backup, which worked with 8.0. Yeah. Replication setup, validation. Validation is nothing but data correctness. So for every single 8.0 copy, we ran through data correctness. So we were confident that the instance we are adding to the replica set was not losing rows and such. And then you bring it online and remove the old instance. So yeah, this is the rough copy process. Now let's talk about the actual process. So I worked on this actually implemented the tooling to make this happen. So 5 phases. The first phase is for every single replica set which is ready for migration, you add a disabled copy. So when I mean disabled, that instance will appear as part of your replica set, but it will not serve any traffic. So you're essentially verifying whether it is able to replicate from the current 5.6 primary and is surviving all the maintenance events and other things happening in the replica set. So this is the first step. We land a config change, say that, hey, add a 8.0 copy in region X for this replica set. So
Does 5.6 to 8.0 replicate well?
Yep.
Well enough.
Yeah.
I can talk a little bit about that later as well.
Yeah. So this is the first step. The second step is once we are confident that there is nothing wrong, slight transition issues. Okay, so add the copy, it appears like this. So for users, no real impact. It's just for us to verify. Next step is to, yep.
Yeah, quick. So when you did the restore into the 8.0
Mhm.
version, did you find any big problems in terms of data types or anything that was really standing out because of the difference between 5.6 and 8?
At this point, no. You mean like how it appears, the size of?
When you restored
Yeah.
the database, did it restore without any errors?
It restored without any errors.
Yep.
If you were keeping any kind of incompatibility, but
Yeah,
I
incompatible, yeah.
I understood properly by the time they are doing this, they invested a lot of time on making sure that
Yeah.
the applications will not keep any
Yep.
incompatibility when they were going through it, right?
Yeah.
Yeah. The biggest catch here was collation, because create table on 5.6 doesn't have a default collation, whereas 8.0 assumes UTF-8 and before. So that immediately causes a replication error between 5.6 and 8.0.
How do you fix that?
We added some functionality to 8.0 to default to the old collation.
All right.
Yeah. So
Cool. Yeah. So
that's,
essentially, that step of validation is where we, Cool. So next step, as I said, we now essentially enable that instance. This is when applications are actually starting to read. It's not necessary that they connect to secondaries. Not everybody is using all copies of their data. This is something we learned later in the migration, that some applications only query primary and write there, and they use the secondary copies as just as an availability thing. But there were some who started reading from the 8.0 secondary, and at this point we kind of also saw differences in plan select queries and such. So we were able to like identify and fix those. Whenever the migration was going on, data correctness, select correctness, all were running constantly in the background and producing results, and they were flagging issues as we were doing the migration. So what we did after this is we had one copy. Now it's time to replace all the other regions. So we essentially doubled the topology of the replica set to be with 8.0, and you have them enabled for reads. Note that all of this is a config change. No DBA is manually going and scheduling copies. We have automation like a daemon which runs on every single production server, and it knows what the topology of the replica set is. It listens to changes, and it essentially tries and maintain the desired topology as defined by the operator. So yeah, it was adding copies, and now we have we are ready for our last step, which is promoting the one of the 8.0 copy to be the primary. So that's what happens. We enable okay, now this 8.0 is available for primary traffic. Let's promote it. So we basically promote it, and then now for a brief moment of time, this is the topology, and once this is done, we verify the writes are okay, and once that's deemed okay, we then disable the 5.6 instances just to be extra sure, because this is a big migration and you're dealing with data. And once we're reasonably sure, like 100% sure there is absolutely no problems with the 8.0 traffic for that particular replica set, we go ahead and drop all the 5.6 instances, and then the migration is complete. So we went through this process for every single production replica set in the fleet. Yes?
Did you experience any downtime when you upgraded to 5.6 prior to 8.0?
No downtime. It is a live promotion, so there might be small errors during the swap, but it's transparent to the.
What was your rollback plan after that?
Huh?
What was the rollback plan?
Rollback plan, if the, for example, we found an issue with 8.0 primary, we are able to quickly promote the 5.6 copy in the replica set back.
After the cutover?
Yeah, you can move back and forth between versions, so it was not a problem.
Did you have to do it?
Yes. Which is why this was helpful, because some of the problems we saw only in, we did so much testing, but still we were finding problems in production which were unavoidable. I mean, in hindsight, avoidable, but we did find. So having this flexibility saved us a lot of pain in dealing with incidents in production.
Then presumably, if you've done that and written to the 8.0 primary, you may have had to check whether you needed to push back some changes which you
Yep.
push there back into 5.6 using whatever method
Yep.
you decided.
It was replicating.
Yep.
Replicating.
Oh, and okay, well,
So we'll talk about issues where developers were so eager to use new features, and they started using JSON on 8.0 primary, and the 5.6 replication broke, and at that point, we can't maintain. Yeah.
When after you did the promotion, you said we made sure that there were no errors. Is that we waited
2 weeks.
an hour, 2 weeks? Thank you.
Yeah. 2 weeks on average, yeah.
Okay.
Don't ask why that number. Just a random safety time. Okay. Yeah, so that's the migration process. And again, automation helps. An animation where explains this nicely. So, yeah.
What'd you use to make that?
I didn't make it. Worked with the animator internally to help make it. So, all right. I'm gonna. Okay. Next step is monitoring. Mainly talking about some counters which were useful during this process. InnoDB transaction status helped identify some deadlocks. Again, Herman will talk about it later. Slow query logs, so we basically exported all the slow query logs to a central database, like a query processing thing, and we were able to like aggregate on versions and figure out like if for a given shard, the overall query times increased or decreased, not decreased, we only watched for increases, and we were able to actually use this data set to find issues and proactively detect for our customers. Second metrics, again, InnoDB rose red. As soon as we flipped something, like enabled an 8.0 copy or moved 5.6 to 8.0 primary, we saw a huge spike in number of rows being read. Again, optimizer plans, we were able to tell by monitoring the metric here. Replication traffic statistics, this is interesting. We had a Facebook feature which had a bug during porting process where we were not computing length of a certain event, and we were logging way too much rows query log event data on bin log. So the bin log write rate was very high, was burning CPU on the primary. And again, somebody asked this question. These were the times where we flipped back to the 5.6 primary as soon, because you have to actually fix the server, produce a new RPM, and then do the upgrade. So again, this sort of metrics were impactful for us. Client errors, again, mainly reserved keywords were easily available here, so we could quickly like monitor it and move back if required, or disable the copy. So we had that flexibility to easily like stop the problem from bleeding. Core dumps, this is interesting. So crashes do happen, like you said this morning, Simon. And we have a data set which tracks all stack traces of all 8.0 crashes, and it has some sampling, and we see crashes happening, and if we don't recognize the backtrace and it's a new backtrace, our engineers quickly looked at it and either worked with fixing the issue themselves, or worked with Oracle to get like a patch or find when in upstream it is fixed and port that patch back. So this was also like another interesting metric to watch for during the migration.
Because at that time you were upgrading to, like, let's say 8.0.20.
Yeah.
8.0.25 was
correct.
Yes.
Yes. So a lot of the times we found that the issue was either fixed in 8.0.28 or 8.0.27, and we had to find that one specific Git patch, and then Herman used to go and scoop on the internet and or look through the Oracle bug report and port that over.
And Oracle is just releasing everything in a single.
Yep.
Like it's not many PR armor, so it's like detective work.
Yeah, I have done detection myself. I've gone through Git commit. You know the file where the crash happened, then you look at the history of the file, and then look at the stack trace name, and probably find the evidence in there. So it was basically reverse engineering, if you may call it. Cool. That's about migration. I'm going to give it over to Herman, who will describe different pains we experienced. So yeah, over to you, Herman.
Sure, thanks. So as Pradeep said, we try to catch everything in testing, but nothing's ever perfect. So these are kind of some of the production pains we saw, some of the more interesting ones. They're basically a series of war stories, I guess, at this point. So lock wait timeouts, because we were moving from 5.6 to 8.0. When we flipped the switch on a number of primaries, there were workloads that came back and started reporting back, hey, we're seeing a lot more lock wait timeouts that are happening, and we're trying to figure out what was going on. So when we enabled deadlock detection, we saw that all of these insert queries were just deadlocking for some reason. And when we went through the list of bug reports, we found a case where Oracle fixed locking in 5.7 and 8.0. They improved locking. They made certain things work correctly, but what that meant was a lot more locking was happening. And in this particular case, it affected tables that had auto-incrementing primary key and a unique secondary key. So whenever you have concurrent inserts into this table, they would just immediately deadlock against each other. So it made whatever was working correctly in 5.6 just completely break on 8.0. The solution for this was relatively simple. Because we were already running on row-based replication, we could have recommended that they switch over from repeatable read to recommitted isolation level. And because we've analyzed their inserts and they don't really care about the transaction isolation level being at repeatable read. And after this, when we start rolling out new primaries, we start monitoring for all the deadlock stats as well, so that we can immediately detect this happening. This is one of those cases where it only happens in the primary, so your testing is going to be somewhat limited in terms of actually catching this before you roll out into production. So I think I've spoken to some other folks who actually saw this because they were rolling from 5.6 to 8.0 as well, so that we were not the only people to have hit this. And so the next class of problems sort of or what I call failability issues. So either service crashing or replications breaking. The worst problem that I saw was an InnoDB table corruption that required us to actually go back to an earlier version of 8.0 or to 5.6. In this particular case, we had a table that had large blobs that were constantly being updated and deleted. Purge was running on these blobs, and if you were to throw in cloning that instance and replaying redo logs, those clones would eventually show up with corrupted instances. So this is one of those cases where we upgraded to 8.0.23, everything looked fine because the upgrade's fine. But sometime later, the load balancer kicked in and started making more copies of these. And once enough of your existing replica set were replaced by these new copies, all of those copies at a day or two later started reporting back crashes in InnoDB. So we got to the case where we actually had to go back up in order to resolve this particular issue. We were able to figure out, based on the bug reports, what the actual problem was and make a fix through the mini transactions that were being scheduled in the redo logging to fix the actual issue itself. So that was a fun one. That was probably, the hardest one that we had to solve. The new temp table. So we had queries that were running correctly in 5.6. When they switched to 8.0, instead of using memory storage engine for creating intrinsic temp tables, we used the new temp table. But certain queries would immediately cause crashes to happen. And for that, we very simply just roll back to the memory temp table and support those. Now, replication is a big part of allowing us to mitigate problems when they happen. However, in certain cases, we lose a 5.6 instance. And in this particular case, DDLs, especially DDLs that make use of new 8.0 features. We don't heavily advertise these features to our customers until we have complete the migration, which means removing 5.6. But some people, they log onto the 8.0 instance and they say, hey, this is new JSON function, this is new Dockster function, let me try it out. And they do a create table, data JSON, and obviously the 5.6 instance completely barfs on that. We've saw similar issues with collations. So we've tried to fix as much as we could. But depending on the client being connected, depending on how the create table statement is being corrected, the 8.0 instance may log the fact that the collation is UTF-8 MB4. And that also barfs on a 5.6 instance. So in those cases, most of the time, the 8.0 instance has been running for a while, and we could just drop the 5.6. But this isn't a foolproof mechanism, and there are definitely pitfalls here. The last one, which is one of my favorite, it turns out we actually had some application using XA. And XA in 5.6 is completely broken. So we were not expecting anyone to be using XA, because in 5.6, XA doesn't generate any bin log entries. In 8.0, they do generate bin log entries. So the instant you switched over XA to an 8.0 instance, it would start generating these 8.0 XA bin log entries. And the 5.6 instance would just stop replicating as well. So this is one of those things where there's some toggle on the ORM with the connector that says, hey, use two-phase commit, and they just turn it on.
SQL alchemy.
SQL alchemy, yeah. So again, unexpected, kind of fun, but it took us a number of hours in order to get the replica set back up because all of the 5.6 secondaries were broken. We were using dependency replication, which we found a bug with XA, so all the 8.0 secondaries were broken. So we had a single instance running for this particular application. And it took us some time to recover everything, but I think I've got more gray hairs from that. So, all right, the next class of problems are performance issues. And these are sort of unexpected as well. So skip scan. So skip scan is a range scan that one of our applications use fairly heavily. Now, the amount of memory that's consumed for each inless entry increased in 8.0 versus 5.6. So this is not immediately obvious, but it is in the documentation when we went back to take a look at it. So what would happen is the application would send us a query. The optimizer would say, let me see if skip scan works. And then if it works, then great. Now, the problem comes when the application starts to batch more of their in-list arguments together in the same query. so that you end up consuming more memory for skip scan. Especially in the case where the application is experiencing problems, it starts to batch more and more of these together. So at some point, the skip scan optimizer uses so much memory that it hits your limit on how much memory the optimizer can use, and it falls back to a full table scan. So every single query at some point just started issuing a full table scan in these huge tables, and basically your server crawled. Now, we can reproduce the same problem on 5.6, but because it required less memory for skip scan, it required a much higher threshold of endless conditionals before you hit that issue. So this is not something we expected. This is something when we migrate them over to 8.0, everything looked fine, but it's just one of those things that come up in production.
Is the range optimized on max memory usage?
Yeah. Yep. So.
We've been bitten by that a lot as well.
Yeah. So it's definitely a good place to be watching out for problems. We've also hit a couple of different deadlock contention issues. So the ACL cache was moved into the metadata locking system. And what we found was when you have a high number of incoming connections, and at the same time, there's some connection that's issuing a flush privilege, which meant that all your connections now are deadlocking on the ACL cache. The metadata locking system also implicitly does deadlock detection. So you're basically at this point single threading through your deadlock detection for all of the thousands of connections that's coming in. And since we have a fairly short timeout on connection setup, things are timing out on the deadlock detection and then reconnecting, and that was just causing a positive feedback loop that basically hosed the system. So we basically had to write a small change in order to remove the deadlock detection in this particular case in order for it to behave the same as 5.6. And so bin log mutex contention, similar case where we have some automation with queries for bin log status fairly often. And we've made changes in 5.6 where we skip opening every single bin log file to query for status. We just cache at one place. Unfortunately, 8.0 added encrypted bin logs. And so there's a functionality that goes through every single bin log, opening it to determine whether it's encrypted or not. So while you have a small number of bin logs, this is not an issue. When you have hundreds to almost thousands, perhaps, of bin logs, going through every single one of them is going to require you to hold on to that lock for the index. Now, if you know how writes happen, in order for bin log rotation to happen, it has to actually acquire a lock on the index file as well. So you basically end up stalling writes because you're doing show bin log status, which is also not expected. But these are definitely kinds of problems that people should be aware of. So, and then lastly, all the default settings for performance schema, memory usage is just not great because you end up burning a lot of memory within the system. So we've actually had to go through performance schema, figuring out which ones we need to turn off, and also making changes into the server itself to remove certain tables so that we don't end up burning a lot of memory for just performance schema statistics tracking. So, any questions so far? Okay. I think we also have a class of issues which are rebasing issues when we take our features and port it on top of upstream MySQL. So read-only database, something I mentioned earlier. This is kind of a fun one. So we have a feature called read-only database. That means you can set a database schema to read-only. It basically stores a read-only key in the data dictionary that says this is read-only. Upstream MySQL in 8.022 also added a similar feature, which is great. Downside is they use the same key. So when we ported this, naively, the key was renamed from read-only to FB read-only. What we didn't realize was that existing servers that had written out read-only was now the upstream implementation was interpreting that value, and the way to interpret that value is different from how we interpret that value. So the instant we pushed those servers to pushed out the new build, all of those database schemas came up as read-only, and instantly write started failing to them. So this is probably not something, unless you're rebasing constantly, would happen, but this is one of those gotchas that we've had even once we are in 8.0. And the last couple of ones, data correctness, we've mentioned before. For floating type, even just between minor versions of 8.0, there's a higher likelihood of floating types being returned in exponential form. So instead of returning 0.2, they may return 2e to the -1 more frequently. That meant that our checksums that are being calculated on these strings change. And so we can't use data correctness in these particular cases to determine whether or not the tables are consistent between different versions. So this is also one of those areas where I think in 8.0 there's more changes that are happening that are more negatively affecting our automation. And the last one, not everything is on the server side. We also have a lot of applications that are using older clients. And in one particular case, an application was using an older version of Django, which used MySQL as the backend. Django had fixes for regex operations between 5.6 and 8.0, but because their version was so old that they didn't have the fixes for 8.0, so they ran into issues that we were able to help them identify and figure out which patches to port over. So a lot of fun working on that. But if there are any questions, if not, I'll turn over to Pradeep. Cool.
Here's a question.
Oh, yeah. We do have tables with partitions, yes.
Did you see any memory leaks on those tables from 8.0?
I do not believe we had. So I think if we did see machines ooming, then we would probably have heard about them.
You mentioned performance schema uses a lot of memory. How does it manifest itself? How much?
Yeah, so we have metrics in which we determine how much memory is being used by the 5.6 server. And then we look at the resident memory of 8.0, and it's hundreds of megabytes more. So then we started, we have instrumentation in JE-malloc, which is what we use to determine where that memory is going. And we see a lot of it's going to performance schema. Then we look specifically in performance schema which tables are using all of that memory to kind of track down, do we actually need these tables? And if not, can we disable them? So.
This specific problem is because I guess running a single MySQL on a server that has 50 gigs of RAM, like the override of performance schema is small, but when you run
A lot of instances,
a lot of
yeah,
MySQL
exactly.
on the same server, then this compounds, and
Yep.
this is why like performance schema is an issue.
Yeah, yeah, because when you're using like 500 megabytes for performance schema, that's a fairly significant chunk of memory just for the instance. And so
Were you guys able to just turn it off in MyLTNF, or did you actually have to change the code?
we had to change the code to make some of those changes work. And so a lot of, I think, stuff around statements or events per thread, we didn't actually need, so we were able to turn those off. But I think we still had to make code changes in order to disable it. So.
So somebody that is running MySQL on a single server, this is not an optimization that they would want.
If you think 500 megabytes for performance schema is not an issue, then sure, right? But I'm sure that 500 megabytes for InnoDB buffer pool is probably more useful, perhaps. So.
But do you get more insight from the new performance schema information?
Yeah, we've been enhancing information schema in 5.6 and now performance schema in 8.0 to look at query statistics, to use those digests. And I know you mentioned earlier about warnings and such. We've actually added tables so that we can return back the warnings that are being returned back, being generated for queries, so that we on the server side know what the clients are seeing, so that we can then go ahead and fix them later. And so.
Yeah, our goal is to use those warnings to learn about deprecated features. And I was able to connect with you when you talked about like things being deprecated. So we want to be staying ahead of those and hopefully make those fixes.
I mean, it'd be good to get that sort of thing upstream, because I think, even now there are lots of changes in 8.0, and you guys are not at 29 yet, and you'll have to jump to another one, so you want to see these things and then be aware of. I mean, the thing is with all these deprecated things, you have deprecated warnings, you can just be aware of them and ignore them for now.
Yep.
But for other things which are important, which you need to pay attention to, you really want to know about them, and if you know about them, then you can decide what to do.
Yeah, I think there's one that I saw which is kind of scary, which is the insert and duplicate key update. I think there's a deprecation that's happening there. And if that query is being used, then you have to fix that query before the next version.
I mean,
Yeah, so.
Cool. Thanks, Herman. So yeah, the last section won't take much time. Just a bit talking about the good things. So data dictionary has been impactful for implementing new MySQL features which Meta is working on. Instant DDL has been greatly impactful for schema changes, and I'm quite excited about the thing. I think the rename column and the drop column thing would be no longer be a slow process for developers.
Save space on the server, that's the only problem.
Okay. JSON functions is super popular. A lot of people use it. Descending index is another interesting thing we had used to actually mitigate a production issue. And yeah, clone is something we want to evaluate. I think once every single MySQL deployment at Meta is 8.0, we want to look at clone and see how we can use it for.
Also, you need to see how to do that with your old MyRock.
Yep.
Which will be, I guess, interesting.
Yep.
Yeah, that's something we're actively working on.
Yeah.
So.
Cool. Some of the lessons learned, so as you could see, we spent a lot of time in shadow testing. So if you're attempting this sort of migration at your own companies, try to have a process around shadow testing. Client software which escapes fields is good, but they also have to be kept up to date. So this is if, for example, if your application is using some sort of ORM. For example, I noticed that in SQL Alchemy, they automatically escape all columns. So it didn't appear to be a problem from folks who are using SQL Alchemy. But if you're directly talking to the server or you are implementing your own ORM, then yeah, it is, because otherwise those changes are pretty hard.
Usually it's easy to fix if you've got access to your own code and
Yeah.
things and you're aware of it.
Yep.
But you have to go through that route.
Yep.
We found that relying on people, saying sure you can quote your column that's
Yep.
called rank or whatever, but relying on everybody to quote everything
Yeah.
correctly all the time
Is
is not reliable.
yeah.
That's
Yep.
just hope, and hope's
Yeah.
not a strategy.
Yep.
So we did the same thing as you. The schema creation interface does not allow you
Yeah.
to create.
So what we did was we added a new linter. So if a new schema is being created, it is going to be a change, and it'll actually flag it on your diff and tell that this is a keyword. Make sure, and they get like enough warnings. We don't block the line, but we allow them to use it because naming makes sense for them. But we now are able to actually determine keywords and proactive.
We actually just limited.
Yeah.
If you go to the schema creation interface and you try to create something called rank, you'll be told no.
Yeah.
You will also have the problem in a query like select
Yep.
X
As.
Y and
Yep. Yep.
rank.
Yep.
And so this is not
Yeah.
discoverable.
Yeah.
But the hope is by the time we're all running on 8.0, if they were to send those queries, they would immediately see errors. Whereas the problem is when you're in a mixed mode, 5.6 would succeed, but 8.0 would fail.
Yeah.
And depending on where they're testing, they may not see the 8.0 signal.
And you may not see every single query that might
Yep.
trigger these things, which
Right.
is horrible.
So
The other thing was backups is important. Test your backups. Restore pipelines have saved our ass here. Like in the incident which Herman described earlier, where we had like the corruption, backups were helpful to actually quickly restore availability to that replica set. So you will need it in times of desperation. Yeah, so that's it. We also wrote a blog post about this on our engineering blog. Shameless plugin. This trended on Hacker News #1 worldwide. Lots of interesting discussions on the chat thread. So pretty proud moment for us. So at least for me, I was a nerd when I was growing up watching Hacker News, and to see it there.
Since this 5.6 and 5.7 data dictionaries are not atomic, I mean the DDLs are not atomic, do you guys have orphan table issues in your production often, like where the FRF file was missing or something of that sort, because that is a major blocker for migrating to Windows. So have you come across issues where the table has gone orphan because,
I mean, I think the number of times we do inline DDL is fairly limited. They don't happen very, very often. So
You've got a lot of data, it just takes too long.
yeah. So like most of our schema changes is performed through an online schema change process that doesn't require us to be able to create the tables atomically. So
Cool. That's all we had.
any questions? Oh.
Are you guys, you can say no, are you guys ever planning to open source that ShadowDB plugin?
I do not believe so, because it requires infrastructure on our backend to support it. It's basically an auto plugin that knows how to talk to our backends.
Oh, okay.
So
But it was a MySQL plugin that you guys wrote, that you load into MySQL?
correct.
Yeah.
Yeah. So auto plugin gives you the same functionality basically. I think there's a question back there.
yes, so you mentioned, how much you mentioned in the slides was what you prefer about the problems that you have in migrating from
Sorry.
6 to 8, that you were talking about the DDL and whatnot. So when he said, I'm going to take it from 5.6 to
migrate a few of us were like, is that even possible? And then he said yes, and you say, well, no, because we had some problems. So what are the main problems you found when you were doing that?
Yeah. So for most general writes, like updates, deletes, and inserts, the bin log format's the same. So you can do replication there without too many problems. For the most part, DDL is fine unless the DDL references some specific 8.0 feature, whether it's collation or JSON. In those cases, then you have problems. And then I think the other one was XA.
So as long as you
Stay away from those.
stay away from those, you are fine.
Right, because technically, when we upgrade to 8.0, there shouldn't be any 8.0 specific features in the application yet, right?
And
So,
I have another question, which is you mentioned you have your own dependency tracker, which is of your own solution to improve replication, so speed replication between when you 5.6. That's your own code. Is that accessible in your GitHub for the changes that you need to improve?
yeah, so this is the dependency replication code. That is in our GitHub. So you can find it on 8.0 as well.
There's
So.
a talk about that Percona Live Frankfurt, the slides are.
Yeah. So we haven't had a chance to evaluate the performance difference between that and upstream write set parallel replication yet. So.
That change requires making changes in the bin log of the source. So you need to add tracking dependencies on the binary log of the source to be able to use your method of the.
No, so our method does not require any bin log changes. It requires it requires row-based logs though.
Only requires that, yeah.
Right, because what it does is it actually checks the key of every single row, and it generates a dependency graph on which transactions can move forward and which ones cannot.
I mean, this is all done on the replica.
This is all done on the destination side.
All right.
Yep. So.
You said you haven't done any comparison between what you guys do and what.
We have not had a chance to
saves.
yet.
Okay.
Yeah, we've been occupied with a bunch of other stuff at the moment.
You're
So.
also doing partial transaction, like you're doing partial transaction execution and dependency. So
Sort of. I mean, the bin logs themselves are still within their whole transaction. It's a question of when you start that transaction processing. And with dependency replication, you can start the transaction processing after the previous transaction has entered into the commit phase. Then you can start processing because any locks that your new transaction needs to acquire, if there's a dependency, is already going to have been acquired by the previous one. So it basically lets you pipeline your transactions through better.
And are you going to expand your code to work with write set, or do you already need it? So.
That dependency replication works for any storage engine.
Right.
So.
No, I mean so you know the write set application. You have write set or write set session. So is your dependency mode working with write set or?
No, it's a different operation. So there's no depends. There's no the different features. So any other questions? All right. Thanks everyone.
Thank you.